Good morning, folks. This is Ashrith here. I work as a principal security scientist at H2O. As most of you know, H2O works basically in the area of machine learning and AI, and also solving specific problems in certain areas. One of them is actually fraud. So, a quick introduction. I'm guessing most of the folks who have actually come in are pretty familiar with what we do, but still, I'll just go over the general things that we actually do. So H2O founded back in 2012. We've had many products that have actually come out. Our primary product one of the main products that was actually we started off with was something called as H2O3, which basically addressed the model building, ML model building for that matter. The next thing that actually came out of our products was something called as driverless AI, which accelerated model building and feature engineering, where the entire process was automated, and the artifact that you would get out of it was a model that you could deploy very easily. Then we followed that up with H2O Wave, which basically puts, which basically brings your model, your data, and everything together to actually make it much more usable to the end user. So if you're thinking of a model as something that your investigators, considering this is a fraud talk, as your investigators are actually working on, H2O Wave can actually bring all of this together as a means of interaction. And then finally, we have a hybrid cloud, which is called HAIC, HAIC, where you can actually deploy a model, not bother about scaling and all of those things, and it's a good platform to deploy. So this is how we have matured and grown across the area of products that we have worked on. Having said that, we've had quite a good number of customers, and then of course humbly so, quite a good number of customers who have backed us in the work that we've done. You can see the list out there. We've got a lot of folks who are excited to work here. So if anybody's interested, just feel free to contact us. Having said that, some of the customers that we have, just a short list. Now that I'm done with the what we are all about in a short statement or a phrase for that matter, let's get to the meat of the talk today. One of the things that that has seen a growth of fraud has actually been the pandemic. Before the pandemic, one of the things that we actually used to see that the growth rate of e-commerce was about 12%. If you look at pre-2008, before the economic crash, the growth rate was anywhere between 20% to about 30% every year since e-commerce was a big deal since 2000 itself. And after the economic crash of 2008, the growth rate consistently sustained itself at about 12 to 17% across the years. With the onset of the pandemic, my sincere apologies, I live beside a very busy road, so you might be able to hear a lot of background noise. With the onset of the pandemic, the e-commerce has actually grown at a much more accelerated pace, which is close to about 32% and 44%. And the reason why there is so much of variation when you look at it, almost about 8 percentage points of variation, is because of the fact that every quarter you see a huge increase in the growth. So if you were to look at it across the last 1 year, you'd see a large variation, primarily because of the good amount of increase that actually happens every quarter. Various studies, as you all might have known, say that this growth rate is actually here to stay. I mean, maybe not at 30%, but maybe not at 40%, but it could probably sustain itself anywhere in the upper 20s to 30s. And that's essentially how the growth rate is expected to be. Having said that, fraud too, especially talking about e-commerce, B2C, online fraud too, has actually increased. The interesting thing is the number of fraud events have actually decreased since the last 1 year. So the year-over-year number of fraud events from 2018 to 2019 increased at the rate of 2.6%. But from 2019 to 2020, the number of events, fraudulent events, actually decreased by I mean, or rather increased at the rate of 2.3%, which means that you had a 0.3% deficit in the increase. But what happened is the total loss of fraud, or the total amount of value that you associate with fraud, increased from 3.7% over the year to about 4.4%. And this essentially shows that the aspects of the areas where fraudulent behavior is associated is being targeted towards high value products, which essentially means that if you're an online merchant or a B2C service company, you still are expected to have a good chunk of your money in terms of fraud, but across much less events as compared to earlier, where the fraud was much more about low-hanging fruits. They could probably defraud you with regard to something, which is worth like $10, while now, there are more sophisticated, complex fraudulent mechanisms where they'll defraud you with something that's worth about $100, $1,000, and that's how they get away with it. And that's one of the reasons why you see this 0.7% increase year over year in the total amount of fraud loss. One of the other big problems that you see across all the categories of kind of things that you sell is that there could be anywhere between 20 to about 37% fraud attempts that you actually face, depending on the category you're in. It could be, like could be a small supplier, a medium level supplier, or a large level supplier. And across average, it actually costs you about 3 times than the product itself to stop the fraud. So when you calculate the cost that you spend on trying to stop fraud, for every dollar you spend, for every dollar that you actually get, you spend close to about $3.36 to actually stop if it's fraudulent. So that's actually very expensive in terms of how you're preventing fraud. And there are very many reasons to it, but one of the fundamental reasons is how we approach fraud as of today. And that's essentially one of the big problems that we all face right now. And having said that, there are many other fraud also creates, like a lot more damages to your business, to your industry, and so on. I mean, you could associate this as direct damage, or sometimes even collateral damage for that matter. If you're not directly dealing with customers, or if you're indirectly dealing with customers, and so on. The biggest problems that you actually have is breaches. You have large retailers. You have many different companies where a lot of your data is actually has been taken out. You have large breaches. Credit card information to the tune of millions are actually extracted from you, and then the same information is actually sold in black market and then further used for conducting different kinds of fraudulent activities. You actually, as a responsible member of an industry, you are also and due to regulatory requirements, you're also expected to pay out for this fraud, for the 1 year or 3 years of monitoring, depending on how much the amount of fraud that has actually happened. You're also expected to cover any losses that might actually happen with these customers, because of what has happened with your e-commerce business or your online business. You could also see a loss of revenue. People might not trust you anymore. They might actually go to your competitor, which becomes a big problem. When you're in a really cutthroat industry, for that matter. The number of services that you actually offer could be reduced. You could be offering, cutting edge technologies. For example, you could be working on cryptocurrency transactions for that matter, that is still under the regulatory purview, not necessarily decided otherwise. And then you could be hit with any of these fraud. You might have to scale down the kind of services that you're offering. You might see a large reduction in your customers for that matter, because people don't trust you, so they don't want to buy from your platform. Not only that, if you're a platform that is very similar to, like, let's say eBay or Amazon or Alibaba or any of these things, where it actually brings in sellers and buyers, you might actually see a reduction in the number of sellers as well. Primarily because even the sellers, who want to make genuine business don't necessarily trust you anymore. And not to forget, you are always you might always face with regulatory fines and sanctions, which could hurt the entire company itself. These are some of the effects that actually fraud causes. So these, you could say that these are the symptoms. You don't necessarily have to address all of these if you address fraud itself in a much better way than the existing setup of how fraud is being addressed today. Having said that, this will just be a brief primer of the different kinds of frauds that we talk about, or rather, that get affected by the approaches that we're taking today. You guys, of course, are very familiar with the payment fraud, the chargeback fraud, refunds, where basically the transactions are disputed and you basically get paid back, and the financial institution that is actually the intermediary to deal with you and the customers charges you the amount that was actually fraudulent. You could be you could be basically a testing ground for card testing, especially if you deal across the board, where you deal with things that are very very inexpensive and that are very expensive. For example, you could have a large retail. So let's take, for example, something like Home Depot for that matter. It deals with really large housing equipment and things like that. But when you're checking out, you also see a lot of knickknacks and things to eat. Maybe a bag of chips or something, which actually costs you much less. So there could be when you're dealing with things that are actually of very little cost. That is very attractive for people, to test fraudulent, to test basically stolen cards and so on. So you could be a victim of card testing, or you could like a thriving place for people to test cards, which becomes a problem as well. If you have a phenomenal online presence, in terms of customers, you could also be a place for account access. If your systems are not necessarily like PCI compliant, or you don't have the necessary security setup with regard to your account access, you could have account takeovers. You could also have something called as affinity fraud, where your systems have actually seen transactions from a customer, and when your customer information is stolen, additional transactions of the stolen information is done from your own systems, because your systems actually know these things, which means that the rules engine that actually work in the background kind of have already approved the customers in there. So which means that it becomes much more easier to do fraudulent transactions using your setup. You could also have associated fraud if you are actually sending out online advertisements. You could have affiliate channels which increase the number of clicks that they've got with regard to your for your ads. They could they could basically enlist bots to actually do this for you. And finally, you could actually if you're someone like a platform like PayPal, I think PayPal is credited for the identification of triangular fraud. You could if you're a seller and a buyer platform, you could actually see triangular fraud as well. So having said this, these are just some basic like a very limited information about the kind of fraud that I'm putting out for the uninitiated, because I know most of you actually deal with one fraud or the other that we are basically showing out here. Having said this, the problem that the methodology that we're actually trying to address today kind of helps you solve these problems or help you solve frauds of this type, using the approach and the methodology and so on. Having discussed the different kinds of the fraud that actually exists, the current day setup is largely rules engine. I think if we were to do a post presentation poll, we might be able to see a lot of people in the rules engine group, or probably a combination between the rules engine and AI rules engine and some more better models and so on. So the idea of rules engine is very simple here, just for illustrative purposes. We've kind of overly simplified it, and apologies if if that's something that's that would trouble you. But having said that, the idea here is that you have simple guidelines, which basically says if the amount of money that you are actually if the amount of money in a transaction, for example, is just $10, and you have found out that historically you don't necessarily have fraud with $10 and above, then the decision basically says, if it's above 10, don't bother, it should not be a fraud. If it's below 10, then it's probably is a fraud, and so on. So it's basically very simple rules that give you a path to decisions. Is it fraud or not fraud? Eventually you come down to a point where there is a fraud bucket, and then there is a non-fraud, or something that's not fraudulent. And largely the bucket that's actually fraud is sent over to your investigators for further inspection. And the investigators go through this entire bucket of alerts that has been generated in terms of the rules. And then, you go ahead and then figure out whether this was actually fraudulent or not, based off other sources of information. And other sources of information could be, supplementary or secondary information that comes from the transactions, comes from the financial institutions, comes from, like, let's say, the website itself, and so on. Some of the very simple examples of how some of these rules engines could run. And also, mind you, the idea behind simplifying some of the rules in these rules engine is to make things as fast as possible. I think that is one thing that probably goes as a credit to online merchants, is that they want to make the transactions as seamless as possible, or as fast as possible, for that matter. Simple rules like this exist, which basically talk about card not present, or card is actually card present and card not present, which is basically identifying whether are you doing this transaction with the presence of a card, or with the presence of not with the presence of a card. Most of the times in an online transactions, if you're not requiring a PIN, it usually ends up with CNP. Or there are different ways in which you can verify the transaction. You could actually have a secondary authenticator, you could have a biometric identifier, you could have a one-time pad, or you could have a challenge response, which basically moves a lot of transactions from CNP to CP, which makes it, which reduces your risk. To put it very simply, you could also look at the location of transaction. What is the distance between the locations of the last two transactions, for that matter? One of the things is that you look at the the geographical distance between last two locations, and if you tend to be moving all around. For example, if your card is being used everywhere around the world, then it's you could be pretty evident in a very small period of time that it's actually fraudulent. Or what kind of risk bucket do you fall into? For example, the one that I was mentioning earlier was, do you fall into something that's sub $10, more than $10, more than $100, and so on. So these are different kinds of rules that actually go into the rules engine that we were talking about earlier. And this is how the current decision actually is made right now. Some of the limitations of rules engine, rules lack flexibility. One of the big problems that we face is that most of the people whom we have worked with, or most of the companies that we work with, basically speak to us in a way where they say, oh, our rules have become so big, or they become so complex, that we are in a situation where we do not know whether there is a rule gap, or we have a comprehensive set of rules, which means that it's overwhelming the system. um, these are two extremes of either over engineering or under engineering. But one of the big the reason why you could fall into either of these problems of rule engineering itself is because individually rules themselves lack flexibility. um, a rule is purely single definition of how a decision needs to be taken. There are no bandwidths for how to look at it. There are no distributions to look at what is acceptable, what is not, what is of a lower probability, and so on. It's decisive in nature, not probabilistic in nature. And rules are basically they're incapable of adapting very quickly to behavioral changes. You might see a sudden burst of activities, where a bunch of cards were stolen, and immediately they were tested on your system. There are hardly rules that gather, that put those two things together and say, hey, this probably could be card testing, and so on. And this quick adaptability, this lack of quick adaptability is one of the big problems of rules engine. Although I do have to say, in favor of rules, speed is one of the big things. And speed, though, is a function, or rather is an outcome of how well the rules are designed, which means that how well the investigators, the industrial experts actually design the rules. Rather, it's an outcome of their strength rather than an outcome of the system itself. Um, and manual inspection is very required to actually verify how good the rules are. This means that you actually have your investigators who are going through hundreds and hundreds and hundreds of alerts before they realize that a rule is ineffective, or before they realize that a rule is actually effective and they need to tweak a few variables associated with the tool's change value. So one of the things that we basically have tried and pushed about is this idea that you can move from a rules engine to actually something that's ML based or machine learning based. In this case, I've deliberately used GLM to illustrate the fact that you do not need complex deep learning models, or for example, like hundreds and thousands of trees to actually build a really good model. You could have a perfectly simple, well-defined, well-designed GLM model, which makes the decision really well for you. It could be as simple as that, depending on the kind of problem that you face. But it gives you it moves you away from the rigidity and puts you in a place where your models are much more flexible to behavioral changes and variables in the data. Having said that, I'll quickly run through some of the use cases that where companies have been successful using H2O itself. One of them is, of course, AT&T, where they've ended up reducing fraud to a large amount. And the way they've measured it is, the inverse way, where the number of fraud events that was not actually stopped has been, has kind of been reducing over a long period of time, depending on the amount of models. And the one thing I do want to point out here is that the number of model is inconsequential to the problem at hand, primarily because when you have an automated system like driverless AI and a scalable system like Hack, you don't have to worry about how many models you're deploying, or how much of data is coming in, or how big the models are, because all of these things are scalable really well. The other use case, of course, is where PayPal, where they've actually accelerated their fraud detection as well, and seen a pretty good increase in their accuracy in detecting fraudulent activities. And they've been using H2O since the early years, and they found value in in what we develop, what we put out, and so on. So I would like to switch to the next part of the talk itself. If you could just give me 1 second.
Okay, everyone, I think Ashrith is changing. Ashrith, are you there?
Yeah.
Oh,
So
okay.
sorry about
Oh,
that, Bruna.
okay. Right.
I'm extremely sorry, folks. I just realized that my laptop was running out of battery, and I didn't want that to happen. So quickly had to go grab a charger for that.
No problem.
Parents are working from
Yeah,
home.
you
Yes.
could. Did you grab it?
Yes, I did. I did. I did.
Oh, okay,
Yeah.
good.
Thank you. So moving onto the idea of optimizing fraud detection with I covered a few areas in which rather low-hanging areas where you could very quickly address and see value in your fraud detection by using AI, and that should kind of give you an idea to think about how to actually make your fraud detection much more optimized using the new technologies that come by. There we go. Okay. So one of the first places that you can actually talk about, or rather see the work, is in the idea of false positive detection. In false positive detection, what you actually see, Rina, give me, guys, give me, I'm sorry about this, give me 1 sec. Yeah. So sorry. So one of the first areas that we can actually address is the area of false positive detection. So one of the big problems that you actually face, which I had very mentioned it in a very small way earlier, was that there are multiple alerts that actually come out of the system, which means that your investigators have to go through all of these alerts to actually identify which ones are actually good alerts and which ones are actually bad alerts, or in the sense which ones are true positive alerts and which ones are like false positives in this case. So what you actually find out here is that you can you basically, once you run through your systems, you identify that there are the current rules engine. Basically, once you run through the transaction and the account information, you can have many false positives in this case. And once you run through this through like an AI model, you could have like reduction of close to like about 80%. So here what you see is that about 10 to 15% of the false positives still remain in your system. So essentially meaning that 100 false positive alerts. So if your system didn't necessarily have about if your system didn't have like AI as a sense to differentiate between what were false positive and what were not false positive, then you would have about 100 alerts which could be classified as false positive. Now, if you were to fit in like an AI-based model to differentiate between this, between the false positives and the true positives, you would eventually have just about 10 to 15 false positives, which means that out of 100, you would have reduced anywhere close to 85 to 90 false positives, or 85 to 90% for that matter. And that's actually a significant amount of false positives that you reduce, which means that you are able to get your investigators to work on much more serious problems rather than, identify or differentiate between what is good and what is bad, which kind of, very quickly brings back value to the fraud detection system that you're actually building, or the fraud detection department or group that you're actually heading. So the advantages of false positive reduction kind of falls into 4 different buckets. You would have something in the area of cost reduction. You would happen to have better customer experience. You would also be able to reduce risk and identify new types of fraud as well. So in the cost reduction, you would see less cost because the number of alerts that you're processing are actually much lesser than what you used to process earlier. And you would also be spending much less time, which equates to money in this case for processing this false positives as well. You would have better customer experience because transactions get to be confirmed much faster, because when you have these systems or when you have these models sitting in line, they could very quickly tell you whether these are false positives or true positives and approve or deny a transaction very definitively. So you won't have them in a placeholder and then review it later on. You will also reduce the risk because your decision is much more objective and you are compliant from the regulatory needs. You'll also be able to identify newer kinds of behavior, which all of us know is one of the big problems that exists in fraud as well, because you will be able to get your investigators to look at newer problems instead of looking at false positives that are generated from old systems. And the second one that we address in terms of the problems itself is you could also, so as you start working on the false positives, you could also identify newer behaviors. The current idea of identifying newer behaviors in terms of fraud is rule-based, or it's a manual approach. You have data that comes out of investigators, data that comes out of rules engine, which necessarily might have fallen into a crack. Then the investigator actually looks at it. It requires a sufficient amount of time, and there could be a possibility of subjective errors as well. In model-based, which is purely data-driven, in this case, you could look at unsupervised models as a means of identifying newer behaviors. You could identify newer behaviors very quickly. It's very objective in its approach. And you could get this to work with your investigators, not just independently, where your investigators could provide human intelligence as a part of this whole equation and try and identify newer behaviors much faster. And some of the advantages. So if you've noticed, we're trying to break down the advantages in terms of where actually you add value. So cost reduction is one of the big advantages that you see in identifying newer behavior. Less cost for detecting newer behavior, which it also increases your value, which means that you have actually detected this behavior much before anyone else has figured this out, and you're able to thwart the problem when it's small rather than when it's a big problem. You also reduce your risk. You've identified these vectors and probably brought up regulatory compliance much earlier, than the other industry folks as well. The third one in this case you could have is to actually refocus your human intelligence, along with AI. You could have alerts that basically are passed through the system to identify alert decisions that are suspicious and not suspicious. My apologies for the textual error. And then you could have the reviewer or the investigator in this case review the alerts and basically, add up intelligence to the system, which basically says, hey, this alert is actually a true positive, while you've identified this as a false positive. And that helps the fraud engine to actually relearn and say, okay, you know what, from now on, I'm able to identify this as fraudulent, while previously I identified this as non-fraudulent. And of course, some of the advantages again with this is you have reduction in cost, which means that you are increasing in value as the investigators are being focused to newer problems, better customer experience, Again, no delays in transactions. You reduce risk as well. The model errors are very limited because you actually have a person who is reviewing outcomes of models. And the interesting part of this is the investigator need not be a person who understands models or data science. The investigator understands the domain, which means that the model or the system on which the model runs, in this case, for example, H2O wave for that matter, just taking as an example, um, would be the one responsible to actually put out information in an intuitive way so that the investigator can absorb it. So this kind of builds a synergy between the investigator and systems itself, where the investigator can understand the outcome of these models, without necessarily understanding the internal workings of the model itself. You could also use this process to identify newer types of fraud, which again adds value to your whole definition of fraud detection in this case. So having said that, I know we've been speaking about H2O AI and the hybrid cloud for about 20 minutes now. But we have not necessarily spoken about how it looks. I mean, it's clearly not a black box, which is one of the reasons why we could lay it out this way. So the idea is very simple across the hybrid cloud. You have a data preparation, which means that your raw data comes in, it's structured, features are actually built, or data is augmented. For example, if you have location data, location specific information, for example, location specific e-commerce crime data could be augmented with this transaction data and then processed further. And AutoML kind of provides the ability to quickly check different models, for seeing value. Autodocs essentially explains your model, which basically tells you, what are the valuable features, why is the model designed in a certain way, and so on. One of the areas that actually Autodoc addresses really well is your need to be compliant to regulatory needs. So when you take this and speak to a regulatory agency and you say, hey, this is the model that we have deployed and it's giving us great results, the regulatory agency almost always comes back and says, but are you sure it actually works and it's not, for example, biased, or like gender biased or racially biased or any of these things? Autodoc actually explains to you the kind of decisions your model has made and the features that have actually gone into it. So it creates a sense, it creates transparency for your model, which means that you can use the document and provide that to a regulatory authority to understand how your model actually makes decisions, which I personally feel is very wonderful, because I have personally used this in multiple situations where I've dealt with regulatory agencies, and the comprehensiveness of these documents, of this information for that matter, is super valuable for them to understand as well. And what I've seen is many of the regulatory authorities come from a statistical background, which means that if you give them information in a way that they can consume, it's much more easier for them to understand how these models work. The other advantage is the ability to operate and deploy models. As I had said earlier, there is the fact of scalability, which gives you the advantage, and the whole design is very lightweight. You can most of the programming that you can do is through high-level programming languages like Python, and we've started to work with support for R as well, which means that you can have your data scientists who largely work in the area of Python and R, code these things as well, which kind of can make it very easy or very quick to prototype at least. And then there's a whole app community, which means that there are many different forms of applications which you could try and adopt for your purpose as well. In terms of, just to speak a bit more in terms of the cloud architecture, it runs on many different platforms, many different operating systems in this case. You completely cloud deployable, Dockerized, and in terms of security, it's very it's closed, which means that it's perfect to deploy these things, which makes it easy as well. So having spoken a bit about the kind of fraud that we actually address, and the areas that you can very quickly address fraud to actually see value, and the architecture itself, I want to go a bit more deeper into things that I actually skimmed earlier a bit, as the reasons why using HAIC kind of makes sense for you to detect fraud itself. One of the things that that actually is very valuable here is speed. Right from H203, H2O models have actually been very fast. They've always been very light and very fast, and equally comprehensive. So speed is not at the cost of accuracy or comprehensiveness in terms of the model. And they're optimized really well as well. So you with the speed, you kind of have the advantage of a very optimal cost and a better customer experience in terms of how you want to see it. And with regard to the scale, so so depending on how many model instances you need, you can parallelize all of these things without losing accuracy. You could stand many of these models in parallel, and they could work really well across the board. So which kind of makes that easy for you to scale depending on the number of transactions that you see. The models are also scalable in terms of the size of data. So, you could have a test data, which is small, and then you could have a data set which is much larger. Your features are easily scalable as well, depending on the change in data size that you actually have. So essentially, you don't lose the speed, you don't lose the accuracy, and you're able to scale. It's kind of, we've optimized it on both sides and then allowed it to scale, rather than first scale it and then kind of try and fix the speed and the accuracy. So of course, this gives you an increase in value, which means that if you were to flip it, it kind of is cost reduction, better customer experience as well, and good amount of risk reduction. And in terms of the accuracy, the engineering recipes that actually go into driverless AI, which is a part of the HAIC, kind of help you build models that have optimized features, and these recipes are actually deploying only features that are useful. So they don't necessarily they don't necessarily boil the ocean in this case. They optimize all the features that needs to go into a model, and that's about it. So which kind of makes it really tight. And the feature selection process is optimized. You could have round robins, you could have tournament styles, you could have many different ways in which your features and your models are actually tested to see the validity of them. So yeah, the accuracy is not at the cost of speed, which means that you'll see both of them together. And of course, a similar set of advantages that you see when it comes to accuracy as well. Because as I've always said, one of the big things about ML itself is not just building great features or building super optimized models. It's actually the idea of being able to explain what you've built, which kind of makes it useful for people to consume in the first place. I could build great models. If I can't deploy it, if I can't explain these models to people who need to use it, then there's no point. If I claim that my model actually is capable of identifying, like a long-term problem in the field of medicine, like cancer, and there is, and let's say I claim that that there is a huge amount of value in this model, but there is no way to explain the model. There is no way to check the validity of this model. The model is not deployable. It's it's super huge. It's not practical. Then I think we as human beings have lost, building out something that is valuable, and which is one of the reasons why explainability is it's probably very I'm very passionate about it because it helps you understand what the model is actually doing, what are its limitations. And models are not without limitations. Let's put that out. ML is not finished. It's not the answer to everything. But what explainability tells you is what is the limitation of a model, how good it is, what where are the things that it still needs to be backed up by human intelligence, where are the things where domain knowledge comes into question, or it needs support from domain knowledge, and so on. And that's something that explainability very well addresses very well. It ensures regulatory compliance and transparency of the model, and most of all, any discriminatory biases. So that kind of brings about a lot more value, intangible value to the model rather than all the other tangible values that I spoke about earlier. Having said that, I'll stop right here. I think we have about 10 plus minutes, maybe, Bruna, and
Yeah,
we
we
can
have
open this
12
up for
minutes.
questions.
We have 12 minutes left. So if you have any questions for Ashrith, please drop them in the Q&A tab. I've also shared a link in the chat to everyone who's interested in signing up for our H2O AI hybrid cloud free trial. So let's see if you guys are too shy today. Okay, we've got one question. Let's see. Explainability is great, but how actually does that work? For example, if you have various ML models like a neural net, how do you explain its output?
So there is a direct explainability that exists with models, and then there is an indirect explainability that actually are there for models. In terms of direct explainability, what we actually do is we speak to you about the importance of a variable in the larger section of a model, the importance of the model design itself, its ability to go across the population of the data set, and where you might actually see limitations in terms of decision making of the data set. In the indirect approach of explanation, for example, you've taken a very fine example of deep learning, in this case neural network. So it's largely a black box. What you do is you build something called as a surrogate model for that reason. The surrogate model is equally representative in decision making, not in terms of the model structure itself, in its decision making. It tries to mimic the same kind of decision making that you can actually have, and that the features that go into the model and the design of the surrogate model, for example, usually surrogate models are GLMs, is what is used to interpret the transparency of the model. And this happens to any model that is seemingly black box. And this surrogate model is then deployed across the entire population of the data set to see, what are the pitfalls, where does it add value, where does it actually, create biases, and so on. So two different ways of explaining, a model.
Okay, we have more here in the chat. Lucas is asking, did you use a separate model to try to identify false positives?
Lucas, quick question for you. Do you mean separate in the sense separate as a problem, or is it something else? Yes. So you can do it both ways. You can actually have false positive detection as a part of the composite model, which means that one of the problems the model addresses is FPs as well, but you could have a separate model as well. If you can club two problems together, for example, FP and new behavior detection, you can have that. It's which will be basically two models composite, and then the decision will have different probabilities, which will basically say, oh, this is a new behavior. and this could be probabilistic as well. So you can kind of look at it on a bivariate plot and say, um, this falls somewhere, towards more new behavior than towards a false positive, and then you could take a decision based on that. Or you could have a purely false positive direction model as well. There is no rigidity in how we design the model. It's up to you as to how you want to define the purpose.
Okay, we have a question from Eric in the chat as well. One of the benefits of rule-based is if you have a high number of transactions, then you need serious throughput power. Models can be costly, so wouldn't it be better to use the model to generate more effective rules, balancing the benefits of statistically based methods and efficiency of rules-based methods?
Absolutely. I think, Eric, I think we all are in agreement with what you say, but the problem that we need to address, apart from this, if it was an ideal world, this should be the approach that we need to go to. But the problems that we actually face now in the area of fraud is that there is a lot of dynamicity in how fraud actually happens. There are newer ways of fraud coming in. There are certain variations of fraud that actually happen, which means that you need to be able to iterate on these models very quickly, and you iterate on the models and then you generate rules. Now, mind you, iterating the model is one part of the process. Generating rules is the other part of the process. But connecting these two is actually the ability for you to explain or interpret a model as a rule. And that takes time. So, which is one of the reasons to avoid, to kind of speed up things. Deploying models directly helps. Now, there is still one problem that comes out of your question, is the question of speed. If you actually have super optimized models, models that are in its binary format, for example, in deployment or scalable, the speed that you talk about is still addressable, when there is infinite ability to scale and the models are kept super minimal to make quick decisions.
Great, thank you, Ashrith. So going back to the Q&A tab, Anshika is asking, how do you address the variation and seasonality in fraud pattern and prevent model performance from dropping?
Variation, I mean, how do you, okay. So the way you look at seasonality itself is you can build many different models for across a year. I could build 12 models across a year, one for each month if you wanted, or you could build one model for the entire year, and then you could account features for these variations of seasonality. For example, you could look at we've seen transactions on Saturdays, for that matter, which actually scale up. So you could build up something that says, oh, you know what, Saturdays, every 7-day cycles, for that matter, Saturdays you have a huge spike. You could build, so whatever behavior that you see, you could featureize it. You don't necessarily have to build it into the model itself. All of these behaviors that you see, the seasonality, the trends, and all of these things can be built as features fed into the model, so the model learns this behavior and then you're able to take a much better decision. Although I do have to say, it's more of an art than of a science to balance between how comprehensive you want your model to be. My model could know the entire history of electronic transactions that has happened till at this point in time, but it could be so heavy that even taking a single decision might be a problem. So you have to define, how much of history do you want to consider before building up the model.
Thank you, Ashrith. We've got a question here asking if our product is based on supervised learning, narrow AI model, and what type of ML models we use, like regression, etc.
All right. So we do, and this part I think is more of a subjective opinion than of how the world thinks of it. I think what we're doing generally, across the board is narrow AI, because we keep addressing specific problems in specific domains, right? So which kind of makes it narrow AI. Having said that, we take both approaches. We take unsupervised for identifying neo frauds, for example, and we take supervise for like defining false positives, for example. So a combination of these two gives you a composite model which tells you, um, uh, something that is new and something that is could look at false positives as well, as the earlier example that I gave. So we use both types. And some of the usual models that we use, we've used GLM as well, which has given us great results, or we could use tree-based models for that matter as well, which gives us good results.
Great. So we're almost running out of time. We do have a last question from
Please,
Nicolas.
Yeah,
I guess that this approach is based on the assumption that you have historic fraud attempts identified, completed, or stopped by the company. But what if the fraud is hard to define on the specific business settings, which I guess is not uncommon, or you have identified such a fraction of all possible kinds of frauds? Is there any approach to this? And if the question is too long, you can see in the Q&A.
No, that's fine. I'm really sorry for the background noise.
It's
so
fine.
what I do want to mention is that this is one of the most common problems that you tend to have, and the way you can address this is by adding additional weights to the kind of behavior. And it's not just adding weights to a certain set of events, it's adding actually weights to unique categorizations of behavior that you look at it. You could have your human intelligence or the investigators for that matter annotate certain set of behaviors as actual frauds. You could basically do transfer learning, where there is a lot of data that's available outside to identify what is normal behavior. One of the ways
home office, that's fine.
Sorry guys. One of the ways we have actually addressed this problem is where we have also inverted the problem, where we have said we know what normal behavior is, but we do not know what abnormal behavior is. And we have normal behavior well defined. And a model detects everything that looks normal, and everything that falls outside the structure of normal is suspicious. And that's reviewed. So that's another way of approaching the problem as well.
Great. So I think we're going to wrap up now. We have 1 minute left. If you want to reach out to us, please feel free to do so. I'd like to thank Ashrith for the great talk, and thank you for the questions that you all brought in. We will have an event, an H2O Live event next week with Shriyambadi, our CEO and founder, and also some of our customers. And I will send you the link in the chat. And also when I send the recording of this session, I can also share this link with you all. So thank you again. And Ashrith, I don't know if you want to say anything else.
Oh, no, nothing else other than thanks, Bruna, and thanks for taking some time out of your day, guys, to listen to the talk. I'm glad we could be of assistance and help you guys. Thanks, and have a nice rest of the week.
Have a nice day. Bye, everyone.
Bye, guys.